Hello everyone, welcome to our channel CodeChef. This is Kusmulata Bhatt and today we are going to solve the problem Birthday of Annabelle from CodeChef platform, which is of easy difficulty level and it requires no prerequisites. Now let's understand the problem statement. Vishal wants to buy two gifts for his best friend whose name is Annabelle. Her age is 20, so they both went for shopping in a store. But Annabelle gave Vishal a condition that she will accept these gifts only when the total price of the gifts is the same as her age times 100. The store contains a list of items whose prices are also displayed. Now Vishal is asking for your help to buy gifts so he can express Annabelle this time. Note Vishal cannot buy the same item more than once. So in this problem, we are given with the array of prices from which we have to select two distinct elements or two distinct items. This basically means that we have to select two items I1 and I2, not the distinct items that like you can understand it as that we have to consider the distinct prices. No, we have to consider the distinct items. So we have to consider two distinct items from the array of prices and we have to make sure that the sum of prices of these two distinct items is equal to 100 times of age of Annabelle here and which is given as 20. That means from the array of prices, let's say A1, A2 to AN, we have to select any two elements such that AX plus AY equal to 100 times of 20, that is 2000. Now let's see the input format for this problem. So in the case of input format, the first line of the input is going to contain a single integer t and t is going to denote us the number of test cases. Then the description of t test case will follow. The next line of input contains a single integer n which is going to denote us the number of items in a store, and after that we will be given with the prices of the n items. Now for the output, we have to simply print accepted if we find any two elements such that their sum is equal to 100 times 20, that is 2000, and we have to print rejected if we do not get any two items such that their sum will be 2000 again. Now let's have a look on the constraint. So for the constraint, we are given t value in the range of 1 and 10 to the power 3, and we can be given up to 10 to the power 5 items, and A1, A2 to AN value can lie in the range of 1 and 10 to the power 7. So here we are provided with the sample input. In the sample input, we are given with one test case. For the first test case, we have n value as 5 and then we are given with the array of 5 prices, that is 10, 2000, 50,000. Now we have to select two items from this such that those items sum is equal to 2000. So here we can clearly see that we are given with 2000 values. So we can take these two gifts and we can simply give it to Annabelle and our output will be accepted for this case. Now let's see how we can solve this problem. So one of the way is brute force. So what we can do here is in the array A1, A2 to AN, we can check out every pair of the element. That is, we will run one loop for the first element, that we are taking the current ith element as the first one, and then we can run another loop for the second element, and we are checking that we are not considering the same element, and we can check that if a of I plus a of x equal to 100 times of the age of the Annabelle, that is, it is the state value which is 2000 here, so we can return true, and else we can look out for the other pairs. So this is one of the way how we can solve this problem. Now on analyzing the complexity, we can see that here the time complexity will go as O of n square and n value can be up to 10 to the power 5. So this solution will give us TLE. Now let's see how we can solve this problem in the optimized manner. So for that, let's sort the list of gifts in increasing order of its prices. And let's have two variables x and y such that x is pointing to the start of this sorted list and y is pointing to the end of this sorted list. So here x will equal to 0 and y is equal to n minus 1, where n is the size of this list. And then we will have a flag variable which is going to keep a track that whether we have found the answer till this point or not, and we are going to run a while loop until x is smaller than y. Now what we can have is, we can have three conditions: that the sum of x plus y is equal to 2000, and sum of, this is actually the elements at x and y, the sum of elements and at x and y is greater than 2000, and the sum of these elements is smaller than 2000. So if the sum of the elements at x and y index is equal to 2000, so what we can do is we can simply make our flag as true and we can break out of the loop that yes, we have finded our answer. And if x and y is greater than 2000, then we will left out with the one element, that we will either increase the x variable and we will decrease the y variable. So we know that if we increase the x variable, then our answer is still going to be greater than 2000, because a of x plus 1 is going to be greater than or equal to a of x. So what we will do here is we will decrease our y variable by 1. So in this case, we know that a of y minus 1 is going to be less than or equal to a of y. So this is going to give us the value less than equal to the previous value it has of a of x and a of y. So in this case, what we are going to do is we are going to decrement ry by 1. Now for this case, when a of x plus a of y will be smaller than 2000, then we are going to increase our x, because we know that on increasing our x, let's say we have the current sum as s1, then on increasing our x by 1, we are going to have the sum which is going to be greater than or equal to s of 1. So by this way, we will find out whether we are given with a pair of elements whose sum is equal to 2000. The above technique is also known as two-pointer technique, in which we select two elements and check whether they met our condition or not, and then we shift our variables accordingly. Now the time complexity of this approach is going to be O of n, because we are traversing our indexes linearly. Now let's have a look on the C++ implementation of the code. So here we are taking the input of t test cases, and then for every test case we are taking the input of the number of items, and then we are taking the input of the items in an vector created of the size n, and then we are sorting this vector in the increasing order. You can also take array in the place of vector, and then we are making two variables as x and y, where x is pointing to the start of the array A or vector A and y is pointing to the end. And here we have created a flag variable which is going to give us whether we have found our element yet or not. So here we are running a loop until x is less than y, and we are checking the three conditions we have discussed, that whether our a of x and a of y equals 2000, and if it is equal to 2000, then we are turning our flag as true and we are breaking out of the loop. And if a of x plus a of y is less than 2000, then we are simply moving our x variable by one position ahead, and else we are remain with the other third condition, a of x plus a of y is greater than 2000, and in this case we are simply decrementing our y variable. Now if we have found our flag variable as true, then we are printing accepted. This flag as true indicates that we have found a pair of element whose sum is equal to 2000, and else we are printing rejected. Now let's run it on the sample test cases. So here it is giving us the accepted answer, and which should be accepted also, because here we have two elements 1000 and 1000. Now let's submit it and check whether we pass all of the test cases or not. So we are seeing here that we are getting the status of correct answer. Now let's have a look on the Python implementation of the code. So here we are taking the t-test cases as input, and then for every test case we are first taking the n as the input, which is going to give us the number of items we have, and then we are taking the input of the list of prices of those items, and then we are making two variables x and y, in which x is pointing to the start of the list and y is pointing to the end of the list. And we are having a flag variable here which is going to give us whether we have found the pair or not. The false value here indicates that we have not found it yet, and true indicates that yes, we have found the elements. Now we are sorting the list, and then we are running a while loop which is checking that whether our x is less than y. We have to run this loop until x is less than y, and then we are checking for the three conditions we have discussed, that whether the sum of those two elements which we are considering now equals 2000. If it equals 2000, then we are turning our flag as true and we are breaking out of the loop. Else we are checking that whether its sum is less than 2000. If its sum is less than 2000, then we are simply incrementing our x variable, and else we know that the sum is going to be greater than 2000, and then in this case we are decrementing our y variable. Now if flag is true, then we are printing accepted, else we are printing rejected. Now let's run it on the sample test cases and see that whether we are getting our expected outputs as same given the problem or not. So here we can see that we are getting the accepted output which is same. So let's submit and check whether we are passing all of the test cases using Python also. So here we can see that we are getting the status of correct answer again. Now let's see the common mistakes which we can have here. So one of the mistake is we are forgetting that n is also equal to 1. So we have to keep check for this condition. If we are doing some other kind of implementation, then we have to make sure that our code is covering this case also. And we have to make sure in our implementation that x is less than y strictly. X should not be x less than or equal to y, because in this case what we are doing, we are considering at last the element twice. It can be possible that we are having 1000 and this 1000 plus 1000 gives us 2000, but we are having the frequency of 1000 as 1 only. So in this case we have to remember that we have to consider the distinct items. The other mistake we can have in this problem is not printing the accepted and rejected in the right case. So we have to strictly remember the cases of the accepted and rejected so that we are not making any mistake in printing these words. So that's it for the video guys. Thanks for watching.